So next type of inductor is bond wire inductors. So in addition to planar spiral, bond wires are also very frequently used to make inductors, but bond wires are 25 micrometer in diameter, so they have more surface area, and therefore the relative loss is going to be less. So when the loss is going to be less, the inductors are going to produce a very high quality factor. So they can well be placed above the conductive plane to reduce the parasitic capacitance also. So they are ideal candidate for RF applications where I want to reduce the overall loss and I want to reduce the parasitic effect. So I can go for bond wire inductors. So the inductance value of bond wire inductance is given here. So you can see it depends on LR. So L is going to be length, R is going to be the radius. So for a 2 mm long standard bond wire, this formula yields a value of 2 nanohenry. So you can get 2 nanohenry inductor when L is going to be equal to 2 mm long. Okay. So this inductor does grow faster linearly with the length, but the mutual conductance will aid in inductance. So you have a mutual coupling between the different parts of the bond wire, which is going to increase the value of L. You know, L is equal to L plus or minus M. So if the polarity is going to be aiding means you will add the mutual inductance term. The polarity is going to be opposite means we are going to reduce the mutual inductance term, right? So here we assume that the polarity is going to aid. So the effective inductance will be L plus M. M is going to be the mutual inductance. And however, bond wire inductors have been used for many years in all the successful amplifiers. Okay, so they say that there might be some variation in inductance value, but that variation is not going to be large enough. So that variation is not going to be large enough. So that makes it suitable candidate for all your amplifiers where you need to amplify a particular frequency. So one recent design is I'm going to use bond wires stitched across a die as a part of VCO. So the temperature coefficient of bond wire inductor is a combination of two effects. One is the linear expansion of wire. So you know wire is a resistance, and resistance, when you increase the temperature, the resistance value will increase. And other is what is the flux which is contributing to your inductance. So the temperature effect depends on these two considerations. One is the uh, uh, temperature coefficient of the wire, or I can say of the resistance. Second one is because of the flux which is going to be produced because of current flowing through the inductance. So resistance, you know, it will increase with temperature, and it will also increase the amount of internal flux. So they say that approximately it has a temperature coefficient of 20 to 50 ppm per degree Celsius. But practically, you may expect from 50 to 70 ppm per degree Celsius. For 1 degree Celsius rise in temperature, the inductance value will rise by 50 or 70 parts per million. So change in inductance value will influence the temperature coefficient also, and that is going to be a negative factor for your